of Advanced Development, leading innovation in additive manufacturing and advanced product development. Please join me in welcoming Mr. Jason Reynolds, who will be speaking on transformation through 3D printing.
Hi, everybody. So, as she said, my name is Jason Reynolds, the founder and owner, no longer owner, of JinkSpot 3D Printing. So, right now in front of you, and then maybe we can pass some of those out so you guys can see them up close. If you want to start handing them out, you're more than welcome to. These are objects that not all of them were printed yesterday, but a couple of them were. So you're looking at objects that didn't exist a couple days ago. This is kind of the magic of 3D printing, additive manufacturing. It's been around for quite a while, I'd say since the 1983, started by a guy named Chuck Hull. And he was one of the first people to realize the commercial aspects of 3D printing and how someone could take an idea, a concept, and create something brand new, something that didn't exist before. Something that he also didn't have to create himself, that was kind of an automated process. And that was kind of the birth of additive manufacturing. So it's the whole idea of transforming ideas into physical objects. We're shrinking the gap between being able to come up with an idea or a concept for an invention and actually able to make that. Whereas before you would need manufacturing skills, metalworking skills, you need woodworking skills, some way to fabricate, or engineering skills, some way to fabricate and make the thing that you wanted to try. Now with additive manufacturing, the ease and access of CAD, or computer-aided development, or computer-aided design, you can create things with very little knowledge, skills. There are so many things that have already been made that you can start making right off of Thingiverse. Thingiverse or printables.com are online repositories of free 3D models that you can download and then tweak to your own specific needs. So you don't need to design something completely from scratch. You can design something that's already 90% there and then just alter it to your needs. And again, that's not something that was possible 40 years ago. And I think it's a really exciting new way to create our world around us. So with that, I'll talk a little bit about me and how I started. So you got a little bit of a hint, but so I started 3D printing back in 2004. So this was when I was in high school. There was a brand new engineering program that I got access to, learning a program called IronCAD. I don't even think it's around anymore. But it eventually became Autodesk, and then programs like Fusion 360 and other, like Tinkercad, came out of that. But IronCAD was a new program. We were able to design a few things, and our teacher just happened to have a contact in the industry, and they had access to a 3D printer. And back then, 2004, these were $1.5 million, $2 million machines. They were very expensive. So for him to be able to finagle his buddy in order to print a high school class's round of 3D printed tchotchkes, that was pretty special. I actually still have it in a box. I should have brought it, but it was really exciting to be able to start my 3D printing journey as early as 2004. Then in college, I did Cal Poly, San Luis Obispo, and I studied industrial manufacturing engineering, industrial technology, and there I got access to, again, 3D printers. So through that lab, I was able to use my 3D modeling skills to create one of my first inventions, a little project called Puzzlers. They were a vitamin gummy that I thought that if they fit together, it would make them fun to eat. And that wouldn't have been possible. I would have had to whittle those out if it wouldn't been for a 3D printer. I was able to create the design, cast a mold out of bakeware grade silicon rubber, and then from that positive, create the negative, and from that negative, I was able to cast these gummy bears that were fit into little puzzle piece shapes. But again, that was just some random idea I had that I ran with and created a product out of. That could have been anything. That could have been any idea that you guys have today. Hey, you know, I thought about this idea, instead of just letting it die there or maybe in a sketchbook, you can create a prototype of it, show your friends, test it out in real life. That's the kind of magic that 3D printing has. So from there, as soon as I graduated college, I did everything but engineering. So as a lot of people will do in college, they will do their major, and then they might do something else. Well, that was definitely my story. I started in sales, I sold cars, I did Salesforce instance designs, I did a lot of marketing, anything not related to engineering. So then when it came to my last company that I was at was called Sungevity, and that was a solar company. I was doing marketing from them. So about a third of the company got laid off in what's called the solar coaster. So solar incentives were good, then they were bad, and then the company kind of folded in on itself. So I was very lucky in the fact that I didn't have to say no to a paycheck in order to start this. That's kind of one of the scary things about starting a business on your own, is saying goodbye to that kind of stability. But I was very fortunate that I was supporting my wife at the time. My wife, at the exact same time I got laid off, just got a job at Stanford. So we had a little bit of stability. And I asked her, hey, can I try 3D printing? I have one in my garage. I'd like to try to make this a business. And she said, I'll give you a year. So I took that year, and I was very excited to start building a clientele. I used a company called 3D Hubs to kind of start 3D printing, seeing if this is something I liked, I wanted to do. And it was. I liked solving people's problems for them. When I was in college, industrial technology is more about solving how to make the machine that makes the things, designing big machinery. Well, 3D printing allowed me to kind of shrink that down, and I got to help people with individual size problems. Someone had an RC car part that needed a custom widget or bracket, and I was able to not only help them design it, but print it, and then they would take that bracket and sell it to their friends. So through no fault of their own, they were just solving a problem that they had. They were able to make a small business and make their money back, not only off the design work, but off the printing too. So the world is rife with opportunity to make new stuff. So going back to my story, I started in my garage. I earned enough with one printer to buy a second, with 2 printers to buy 4, with 4 printers to buy 8, 8 to 16, and then I ran into the electrical capacity limit of my garage. So I had to find an alternate solution pretty quick. So I then took that business model that I had started in my garage, and there just happened to be a retail space across the street. I moved in there, and that was about 5 years ago. So fast forward 5 years, built a huge clientele. I've printed for everyone in the Bay Area: Facebook, Tesla, Google, TI, you name it, I've printed for them. Some really fun, interesting projects, some random projects. I've printed 3D printed larynxes for Stanford so their students can practice tracheotomies. I've printed a lot of human brains, oddly enough. And just, whatever the customer needs, that's what I built my business off of. So it's 3D printing as a service specifically. A little side note, there's a couple of different ways to make money with 3D printing. One is to do what I do in 3D printing as a service. And that's I think, an interesting way to do it. There's always new challenges, you're always meeting new people. But there's also ways, if you have your own idea for a product, you don't need 16 3D printers, you need maybe 2 or 3. And then you can make and design your own products and sell them on Etsy, you can sell them on eBay, you can sell them on Facebook Marketplace to your friends, family, etc. Goes great with Christmas time. So if you have like an ornament that you've designed and 3D printed, sell it to your friends and family in Christmas. You'll make a lot of money. So some of the fun things that I've been able to do because of JinxBot, I don't know if I finished the story. So then my company got acquired in June, and I've spent the last few months transferring over there. So that's the end of that story. So during my tenure at JinxBot, I've been able to meet and work with a lot of very interesting people. One of the things that I did was create a virtual pinball machine. So this was a project that was an open source project. You can find it online. I've updated the link, so if you see my project alongside of it, my links are the updated ones. But It is quite literally a virtual pinball machine. So it's the first 11 inches, and I'll show a demo of what it looks like, but it's the first 11 inches of a pinball. And it's got pinball buttons, it's got the plunger, it's got a little distance sensor, so it actually works that way. It's got joysticks and arcade buttons on top of it so you can play other games, but what the idea is, you can plug this into a virtual reality headset like an Oculus or what have you, and you can play pinball. So then the first 11 inches of it looks like the rest of it, and you're actually playing pinball. What's really neat about this is that when you're playing virtual pinball, you actually feel like you're just playing regular pinball because you're so focused in on what you're doing. You're not looking around, you're not feeling dizzy or sick, and you're actually anchored to something so that when you're actually playing pinball, you actually feel like you're playing. So I'll give a demo of what that eventually evolved into. And if you're planning to go to Maker Faire, you'll see a demo of the Pin Sim as well as a 2-story tall arcade machine that you can actually go inside. So it's a really cool project, and I'll show more about that later. The next thing that PrintCycle or JinkSpot turned into was PrintCycle. So over about 8 years or so of collecting my own scrap material, I wasn't able to, I'm a bit of a hoarder, I wasn't able to let it go. I saw the value of this material and I really wanted to make sure that it didn't go to waste. So I created a nonprofit called PrintCycle that works with actually Los Altos High School as well as other high schools, maker spaces. We're in, let's see, we're trying to get into Waymo. We're in Whisk, which is an autonomous flying car company. Stanford is one of our biggest clients, but we take their scrap material, shred it, and then we turn it into some of these cool products that you see over here. So you'll see the shred if you want to come up later or come up now, I don't care. But then we have chessboards we've made. I don't know if you're passing around, like there's a wall outlet, but those were just cast in regular silicon that I got from Michaels. So they're a mold that you're usually supposed to use, I think, like a 2-part resin. And instead of that resin, I used shredded scrap material, and it would work great. So now I've been able to take 8 years worth of shredded scrap material and turn them into useful goods. So if there was ever a doubt that 3D printing wasn't a sustainable, or it's just wasteful, or you're just making toys, I would say that there's nothing further from the truth. I think because we have such a valuable and useful material, it's not hard for us to turn it into other useful material. It's not plastics that are the problem, it's single-use plastics that are the problem, specifically single-use. So if we can give this material even a second life, maybe even a third or a fourth, then we've not only kept a lot of material out of the landfill, but we've helped make 3D printing a lot more sustainable. So that's JinkSpot. So solving real-world problems. Who's had a problem in their life, raise your hands, that there hasn't been, that one too, yeah. That there hasn't been a product on the market that has been able to solve it. Something custom that you needed that just didn't exist that you wish you would. So it's a fair amount. And how many times have you been able to access a 3D printer and design a product for that particular problem? We've got a couple less. Well, I'm here to tell you that it is very accessible. It's very possible to solve your problems with 3D printing. The problems that you're solving or you're facing today can be solved. And if there are product-based or I'm not going to say it's going to solve relationship issues. For my wife, it definitely didn't solve a whole lot of our problems. But for a physical product, you can absolutely create something that'll solve your needs and be able to make a little money off of it. So being able to iterate, I think, was one of the main advantages of rapid prototyping. And it's even in the name, rapid prototyping. Because you're able to create a first iteration, test it out in the field, and then create a tweak in your CAD design, reprint it, and solve that issue, you're turning a product development cycle from months and years down to days and weeks. And again, that's not something that's been possible in the last 40, 50 years. Before then, manufacturing is an extraordinarily old practice. It's been around since time began. People have been making stuff. And we've been doing this for thousands of years. But again, thousands of years compared to the last 40 years with additive manufacturing. And this is getting into some magic manufacturing. We're definitely not to the point where we can just say, you know, tea Earl Grey hot and have tea made for us like in the Star Trek replicators. But we're getting to the point where you can use an AI, say, I want a teacup, and then it can automatically create a design, slice it, send it to a printer, and start printing without anything but using your voice. That's something that you could do today if you had it set up. I've seen videos on it, I've been fascinated by it, and I think AI is going to change the way that people not only solve their everyday problems with like writing papers or writing emails, generating images, but also designing products. So definitely not a someday, but this is like today. You can start using these tools today to make stuff. So if you are unaware, if you haven't had an engineering class or you're interested in, I highly recommend. There's some of the engineering teachers that I've worked with in your high school today, and they are extremely friendly, very knowledgeable. But 3D printing is basically laying down material one layer at a time additively. So if you've heard the term additive manufacturing, this is opposite to subtractive manufacturing. Subtractive manufacturing is anything like sawing, cutting, removing material away. So additive manufacturing, again, just the opposite. You're laying down material. This could be either through FDM or fused deposition modeling. This could be through SLA or stereolithography, or it could be through SLS, which is a process called selective laser sintering. And each one of them have their advantages, disadvantages, but most of the time, especially kind of at this beginner level, I would definitely recommend starting with FDM or fused deposition modeling. It's kind of the more basic 3D modeling. This is an example of what that type of machine looks like here. And just in the last 5 years, the technology has 10x increased in speed. And when I say that, it's not hyperbole. When I was working with my Creality CR10S Pros, the max that I could push them was 80 millimeters per second. Usually people were printing at 60 millimeters per second. So that 60 was kind of the industry standard. So the new printers that are out now, which are even a year or two old even now, can print at 600 millimeters per second. So that is a literal 10x increase in speed. And the quality has only gotten better. So being able to take advantage of this technology now, it's only going to increase, it's only going to get better, and it's only going to get more reliable to the point where, like I said, you can just say what you want and it's going to start making it. Unfortunately, right now, then we still have to worry about design and CAD and all that stuff. So speed, strength, cost, detail, just going into 3D printing a little bit more. FDM is really good for, again, rapid prototyping. Stuff that you need a version of in a day or less than a day, or even, depending on your print settings, a couple hours. So FDM is really good because it's also very cost effective. The cheapest 3D printer that you can get an Ender 3 still these days for like 200 bucks. And you can get a spool of filament that'll last you quite a while for 20 bucks. So for 220 bucks, you can get a little rapid manufacturing prototyping house in your house and start working on it. I just got a 10-minute warning, so I'm gonna blast through the rest of this and then we'll open it up to Q&A. Rapid prototyping in action. So again, you know, this is a problem that my neighbor had. He needed a latch for his gate, and then we threw it up on Thingiverse so you can get a latch for your gate. You can get, you know, weird products or things that aren't necessarily there, or custom design, or some weird idea that you've never seen before. That's all possible. Virtual reality. So here's that link that I was going to do. We'll send this tab and then we'll show you. So this
40,
is
40 to 30.
wait.
Oh my gosh.
I'll mute that. So that is the pinball machine there that you see, and it's double-faced. So this person is dodging rockets being launched at their face from me. I'm on the other side wearing this interesting coat, but I'm manning the cannon that's inside the pinball machine in virtual reality. So I'm firing rockets, they're trying to play pinball and dodge at the same time. So it was pretty fun. We demoed that at a couple of different virtual reality conferences. And again, if you want to see this in person or want a chance to play, we'll be at Maker Faire this weekend. So if you don't have tickets, get them. They're going fast. Okay, so going back, that was virtual pinball. Again, that was something that I wanted. There's not a place where you can go to the virtual pinball store and get one. You can't do that. You have to make it somehow. And if you have a big enough 3D printer, you can print the whole cabinet too. Circular design, this is just talking about sustainability practices, designing and not wasting material, or designing 100% thick, 100% dense things, being able to engineer your parts for the specific needs so you're not wasting a lot of material. It's just going to circular design. AI and automation, I touched on this a little bit. I would like to touch on it more, but AI and automation can bring a lot to not only designing 3D printed parts, but also in optimizing them. So if you're at all interested in AI, slicers are something to look into, because that will be the next super huge major breakthrough in AI and additive technology, and it hasn't been done yet. So if you guys are all interested in 3D printing and AI, work on an AI generated slicer that optimizes all the parts. You'll make $1 million, guaranteed. Method I use every day: observe, test, sketch, print, test, fail, iterate, go again and again and again. I can't tell you how many times that I've designed something, it's been just a millimeter or two off, and then you gotta go back, make an adjustment. But then a couple iterations, then you have that perfect design, and then it's repeatable after that. Then you can print it over and over again. So you have some really exciting stuff there. Skills for success, start learning all this stuff. I spent a lot of time on that story, I shouldn't have. Pitch your idea in 1 minute to your friends to see if it's viable, and then start making little businesses out of this. There's absolutely ways to make money with 3D printing, even now. So come up with some ideas, start printing with them. You absolutely can. And then, yeah, you have facilities and you have places to 3D print right here on campus that you can use for free. And the Ultimakers and Bamboo Labs that you guys have are great machines. Start using them. You have access to them, because as soon as you graduate, you're not going to have access to them anymore. And then you have to go to the library. And the library's line is very long, and they don't really care about the quality of your part. So use them now. See if it's something that you want to do. Try to do it, because it's an absolute great career path. You can make money at it, not only by printing as a service, but by also making your own business. Make your own money. Don't take a job, make a job. Create a company, hire your friends. This is the message. And then we'll skip that one, and call to action, we'll skip that, and we'll skip that. Questions. I have a couple starter questions. If anybody has any questions about 3D printing, anything that I've talked about, please raise your hand. Happy to answer your questions.
Hi, I guess I'm like very motivated for like starting like 3D printing. So like any advice for like new 3D printers or like want to do it?
Sure.
That's all.
Sure. My advice, if you're new to 3D printing, is just start. Just try to print something. Go to the teachers here. I think it's Adam. I forget. Yeah, that's it. And say, hey, I want to 3D print a thing. Go on Thingiverse, go on Printables. There is literally 1,000,001 3D models. Let's go to thingiverse.com. And I'll share this tab instead. But there's 1,000,001 free 3D models online that answer all kinds of questions, needs. Go on here, find something cute like this cute dragon skeleton for Halloween, print that out. See what it looks like, see what the process is like. It's easier than you think. And then once you have one 3D print that you've done, the world will change. I guarantee it. You'll see the world in a different light. You'll see, well, why can't I make that too? Why can't I make that as well? Why can't I make all of these other products that you see? And the answer is that you can. You absolutely can. And not only that you can, but you can do better. Because a lot of things were designed very quick and not with a lot of thought. So if you take the time to think about it, you can make a better product.
How are you able to start up the business?
It took a while. So when I started my garage, the very bare bones of it is I needed a permit and a business license from the city of Mountain View. You have to register for a tax ID from the federal government. And then that's kind of it. You really just then need a website, and you could start with Squarespace or Shopify or any one of these and create an online store and just start. If you're a student and you're young, just start first. You don't need to worry about a tax ID, I think, until you make your first couple grand. And if you aren't planning on making a couple grand right off the bat, just create a website, create a Shopify, and then start. One more?
Is your hat 3D printed?
It super is. And it also glows in the dark. So I don't know if we can turn off the lights or even if it'll work, but it absolutely glows in the dark. And it is my conversation starter. It works way better than a business card. If I'm standing anywhere and you ask me about my hat, then I get to talk to you about 3D printing for as long as I can handle.
Maybe there's a follow-up to that.
Oh, sure.
Can I have the hat?
No. But you can make your own. I think it's the, let's see, hat. Make one. There's top hats. There's a cool sorting hat. Which hat? Just pick one. And there's this hat on there too. It actually came with a brim, but my son broke it off and I wrapped it in a beanie. There's even fully 3D printed ball caps that are out there. Something little displays if you want to display your hats. All kinds of cool stuff. I'm getting inspired right now. Okay, other questions? We got one right here. Who will get there first?
What are all the different materials that can be 3D printed, or I think I read something recently that tissues are starting to be 3D printed in the medical field, but out of actual
Sure.
tissue material?
Anything that can be extruded can be printed. 3D printing is very similar to a hot glue gun, if you can imagine. So FDM printing, I don't know if we go back, but FDM printing is literally just a hot glue gun that's computer controlled. So you can think of that, you can think of that nozzle down there as the tip of your hot glue gun. And if you're feeding material in there, PLA, polylactic acid, is a very common material. It's one of the cheapest, and it's one that's been engineered the most to be the most 3D print friendly. There's ABS, ASA, PETG, a lot of different other plastics that you can print with, and absolutely you can print with concrete, tissue, human tissue. You can print with pancakes, chocolate, anything that you can extrude and computer controlled, you can 3D print. I think they're 3D printing meat too. That's weird. Yeah.
On the topic about real things to print, have you heard of a resin printer? Because I heard that's different from 3D printing, but similar.
What kind of 3D printer?
Resin.
Oh, resin. Absolutely. So resin is SLA printing, or stereolithography. So resin printing is really great in case you want to make minifigures. I know Warhammer is really popular these days. You can make D&D figurines, but you can make highly complex, very detailed 150, 25 micron resolution figurines, and you can print those. And if you learn to paint them, then you can sell those for a lot of money. People are willing to pay a decent price for those. So
I noticed on the Rocket and some other builds, there was like multiple colors intertwined. Is
Sure.
there like a setting or a certain printer you need for that?
yeah, these days there are some add-ons to printers that you can do with multicolor. Automatic material switchers is the common acronym for that. But absolutely, there's a couple of different ways to get multi-material or multicolor even. So if you just have a regular printer and you don't have access to an automatic material switcher that can probably do maybe up to 4 different colors, you can get specifically like colored filament. There's rainbow filament that like automatically changes colors as it goes along. So it'll start off red and then it'll get green, blue, purple, all that. And if you don't care exactly how it looks, you just want something a little more colorful than like a single color, then that's absolutely the way to go. There's another one that's really cool. It's called a dichromatic filament. And you have 2 different filaments that are extruded at the same time. So if you were to like take a cross section of it, it looks like 2 half circles put together. So when it goes this way, it's red dominant, and when it goes this way, it's blue dominant. So if you look at your print from this way, it looks blue, and if you look at it from this way, it looks red. So that's a really cool way to do it too. But I think what you're talking about is like multicolor filaments, so or the automatic material switchers. Bamboo, that comes fairly standard. It's like a fairly cheap add-on, and I think the Print Lab has those very machines. So if that's what you're interested in, go for it.
What do you do with the trash, like from the filament?
Sure.
Do you turn it into more filament?
That's a very good question. Everybody wants to turn it into new filament, and that's wrong. Don't do that. It's extremely difficult to make modern filament these days. The manufacturing tolerances for filament is 1.75 millimeters, and if you deviate at all from that, you're messing up print settings, you're messing up print quality, and if you're just making filament on your own, that's not a good way to go. If you then take that material and you shred it, like I have some examples up here, you can shred that material, and once it's in a shredded material state, you can do anything with it. I've made chessboards, I've made pressings, and then laser cut those pressings. I've made guitar picks, I've made outlet covers, I've made chess pieces. Really, it's anything that you can melt into a mold that you can make with that material. And it's pretty versatile. So if you look up online how to recycle 3D printed material, you'll find a lot of resources because a lot of people are looking into this.
All right. Why don't we thank Jason for a great talk? If you are staying for the second speaker this period, just stay put for